Hello and welcome. Today we will cover EGT1, Task 1 on Marginal Analysis. My name is Wade Roberts, and I will be your guide through this task. My PhD is in economics from the University of Utah, with fields in development, labor, public, health, and gender economics. The areas that I currently perform research in, specifically in the country of Cambodia, are in the microfinance sector, dealing with different poverty, inequality, and socioeconomic issues. In preparation for Task 1, it's critical that you read chapters 7 through 11 in the McConnell e-text. Make sure that you focus specifically on chapters 7 and 8. The task asks you to write an essay with a suggested length of 1 to 3 pages, specifically where you're going to explain the relationship between marginal revenue and marginal cost, and the importance of these concepts for profit maximization. Then you are given specific task elements, A through F, in which certain questions will be asked. You'll see those questions in boxes throughout this presentation, specifically in areas denoting the questions or the elements that are relevant for those questions. When you write this essay, please consider writing it in outline form. We suggest doing the following. Start with detailing the letter A for task prompt A. Directly beneath, answer the question, and then start with element B and continue throughout the rest of your paper. This helps to structure your argument, and it makes it easier for the graders to realize where your answers are. However, when you do this and following the outline form, do not include the question along with the task prompt letter. This will only increase your Turnitin score. The scenario that is given for Task 1 is the following. Company A is a producer of widgets in a monopolistically competitive market. It is projected that as more widgets are sold, Company A must offer a discount on each one in order to ensure adequate demand. Due to limited supplies and the cost of equipment maintenance, the cost will rise as more widgets are produced. What is a widget? A widget is nothing more than an abstract unit of production. You can think of it as good X or service X. Oftentimes people use filler words such as thingamabob, thingamajigger. Many other words are used in this application. Economists use widget for this filler word, specifically this abstract word. If it makes you more comfortable to use a different word, go ahead and fill anything else in there. They're producing toys, they're producing airplanes, they're producing bananas. It doesn't really matter. The concept is theoretic, not empiric. I provide data in this presentation that is not actual task data. However, it follows the same design. This will help us to work through the problem sets and to understand the concepts using specific data while not using the data that you're required to use in the task itself. A table is provided right after the scenario in your task, in which you're given a column for quantity, total revenue, denoted by TR, and total cost, denoted by TC. Here you're given specific numbers. You will not have to calculate any numbers on the total side of the equation. These numbers are specific to the widget production levels. Accordingly, you can think of it as follows. On this chart, we have quantity 1, meaning that one widget is produced. When one widget is produced, the total revenue would be $120, and correspondingly, the total cost would be $33. If we were to consider the 10th unit of production, where quantity here is 10, we can see that total revenue is now $840, whereas total cost has changed to $627. You will be required to explain profit maximization according to two approaches. The two approaches that are delineated are the total revenue to total cost approach and the marginal revenue to marginal cost approach. Let's try to understand the total revenue to total cost approach for a moment. The columns we saw on the previous slide denoted the total volumes for revenue and cost. Total revenue is calculated by multiplying price times quantity, meaning that if you sold one widget for a specific price, you would multiply that price by quantity 1, and that would give you your total revenue. Total cost can be calculated through various approaches. You can look at it through the lens of fixed and variable costs. You can also break it down in accordance with capital and labor composition costs. Profit is simply total revenue minus total cost. What this means is that as the firm takes in the total volume of price times quantity and subtracts out the costs that they had to pay in production for the widget, what they have left over is their profit. In an effort to maximize their profit, according to this total approach, you would look for the area in which the gap between total revenue and total cost was the greatest. Marginal revenue, marginal cost approach is a little different. Instead of looking for the largest gap in a profit maximization direction, you are looking to equate marginal revenue with marginal cost. In order to do this, we will need to understand what the term marginal means and then apply it in this approach. Marginal speaks of the next incremental unit. Marginal change in revenue can be denoted by the change that takes place in total revenue, making accountability for the change in quantity. For example, if total revenue changes by 5 for the next unit of production, the next unit of production meaning that quantity changed by 1, then we can say that marginal revenue is 5. We will get practice with this empirically as we actually apply it to the numbers in this task. Marginal cost is simply marginal concept applied to the cost framework. Marginal cost is specifically and mathematically the change, which is denoted by delta, that occurs in total cost divided by or making accountability for the change in quantity. Again, total revenue is equal to price times quantity. This is important for producers because they're looking at maximizing the total revenue that they have, and this can be done through approaches of price or quantity. Oftentimes they know what demand they have, at least the demand that they've had in the past for their product at different price arrangements. Quantity is often something that is done through promotion and advertising. In an effort to increase quantity, you try to make it so that your product is more attractive to your prospective audience. Again, marginal revenue is equal to the change in total revenue divided by the change in quantity. You'll see this equation several times throughout this presentation. In fact, anything that you see that is bold and in this aqua color is critical to the task that you're about to do. Let's look at total revenue and marginal revenue in pure competition. In order to do this, let's understand again that there are 4 delineated market structures. The delineation takes place in accordance to a spectrum of competition. More precisely, when there is no competition and there's only one firm that produces a commodity, we call this a monopoly. As we move away from the absolute extreme of no competition, we get closer to no competition, but there's still slight competition. We call this oligopoly. This is another market structure. The third market structure is called monopolistic competition. This is the market structure that will be critical to understand for this task. The fourth is called perfect or pure competition. This is where competition is complete. There's argument inside of economics as to whether or not perfect competition actually exists anywhere. Theoretically, it exists in the short run, but empirically we don't observe it, or at least we don't agree upon observing it anywhere in the real world. Here we can see a horizontal green line here at 131. Notice that marginal revenue here is 131. When the demand curve is perfectly elastic, this is indicative of perfect or pure competition, meaning that if anyone were to charge a higher price than 131, no one would buy their product. And if any business that was selling this product could sell it for less, they would capture the entire market share. Here we assume that there are thousands of producers producing a homogeneous product, and they're all selling it for exactly the same price. Accordingly, we find that the marginal revenue curve is flat. Total revenue is comprised in adding up 131 for each incremental level. So from 1 to 2, we add 131, getting 262. We again then add another 131, getting 393 for the third level of production. This gives us a linear slope for the total revenue curve. Total revenue, being price times quantity, can be applied in a mathematics sense in an effort to understand this more clearly. Marginal revenue, as we stated, was the change that occurred in total revenue divided by the change in quantity. If we simply plug in our understanding that total revenue is equal to price times quantity, we can take this equation here and expand it to price times the change in quantity divided by the change in quantity. Notice that we have change in quantity both in the numerator and the denominator. When we do this, we can simply cancel these out. We are left with price is equal to 131. Marginal revenue is the change in total revenue that results from selling one more unit of output. The average revenue is also the total revenue divided by quantity. Again, total revenue can be expanded to say price times quantity divided by quantity. Canceling out the two quantities, we're again left with price at 131. The conclusion is that if we are operating under the umbrella or auspice of perfect or pure competition, we can state that the demand is equal to the price, which is equal to average revenue, which is equal to marginal revenue. This is one of the reasons why economists like to start with the market structure of perfect competition. Even if it is not as realistic in life, it is easier to compute on paper. Total costs can be broken down into fixed costs and variable costs. When we add these two up, we get total costs. If we take the total costs and divide it by the quantity, we can get an average. And in regards to the marginal calculation, we simply take the change that took place in total cost and divide that by the change in quantity. Let's look at the total revenue, total cost approach of profit maximization. Bear in mind that the sole purpose that the business exists is for profit maximization. Here we can see several columns where we have total product, the quantity, so this is a level of output, how many of widgets are being produced. Here we have a fixed cost, and indicative of being fixed, you can see that this is 100 at every level of production. The variable costs, the number here change, and when we add up the fixed and variable costs, we can get a total cost figure. Here we have the total revenue figure. Remember that profit is maximized where the gap between total revenue and total cost is the largest. Here we can look at it more clearly. If we take total revenue and subtract total cost, we can get the specific profit calculation for that level of production. More precisely, when output is 0, costs are 100, and revenue being 0 gives us a profit or loss of $100. When we change our output to produce one widget, we now find that the total costs increase to 190, but the total revenue is 131. Here we still have a loss of $59, but it's less. And as we continue to look at various levels of output, we can start to see here that after we get to the third level of output, we're now running a profit instead of a loss. And that profit continues to climb to 185, 236, up higher, until it reaches 299. And then something happens. It actually goes down. At the 10th unit of production, we find that it falls to 280. At this level of production, the 9th unit of production, the gap between total revenue and total cost is the largest. And accordingly, this is the level of production that would maximize profit. Graphically, we can see the same thing. Our total revenue being this very linear slope here of 131 per unit is compared to the total cost, which decreases and then increases, giving us this shape here in the middle that starts small, gets larger, and then ends up getting smaller. This green area here can be perceived as profit. Now, note that we have different types of profit statements that are made. A normal profit is where the break-even point takes place, meaning total revenue is equal to total cost. This does not allow for an economic profit. We again reach this point at point B. Because total costs are increasing, they eventually get to a point where again they cross the point at which total revenue slopes. Accordingly, beyond that point, we would again find a loss. Inside of this green area here, we can find profit maximization again, simply by noting where the gap is the largest. Anywhere where total revenue is equal to total cost, we will find what is called a normal profit, or a break-even point. There are typically two break-even points in a structure as such. Very important to understand that normal profit is not the same thing as economic profit, and when you are asked to find the point at which profit is maximized, we're talking about economic profit. Any output decision between the two break-even points, anywhere in the green here, would yield some degree of economic profit. However, there's only one point at which this profit is maximized. For further information about this, you can refer to the McConnell text, specifically page 167. In summary, points A and B, total revenue is equal to total cost, yielding a normal profit. Anywhere between points A and B, total revenue would be greater than total cost, thus yielding an economic profit. However, there is only one point where this profit is maximized, and that is where the gap between total revenue and total cost is the greatest. Let's look at the second approach. Marginal revenue, marginal cost approach. In this approach, the firm is going to compare the amount that each additional unit, please note that that is in blue, that is a very critical point when we're talking about the marginal aspects. Each additional unit of output would add to total revenue and to total cost. In other words, the firm's going to compare marginal revenue and marginal cost at each successive unit of output. Marginal revenue, again, is the change that takes place in total revenue when making accountability for or dividing by the change in quantity. Total revenue, as a reminder here, is nothing more than price times quantity. And again, marginal cost is the change that takes place in total cost resulting from producing one more unit of output. Total cost is a function of the fixed costs and variable costs combined. Please note that this example here is going to assume perfect competition, meaning that the marginal revenue will stay the same at every level. Perfect competition is not the market structure that you will have to adhere to in your task. Here, let's look at the columns. We again start with the total output or quantity output of widgets. The next columns are total revenue. And then we have a total cost output. Next, we start to look at the fixed costs, the variable costs, the average costs, and then we end up with a marginal cost calculation. Let's look at how this was derived. We have $90 here at the first unit of production. Where did that come from? Notice that the total cost over here in the third column went from 100 to 190. How much did it increase by? It increased by 90. That's the change in the total calculation. We divide that by the change in quantity, which is 1, and we're left with 90. This is how we calculate marginal. We continue to calculate this for all of the successive numbers in output quantities. Marginal revenue is going to again stay the same here at 131. Now, what do we do with this information? Let's consider the following. If you were this firm and you were producing at 1 unit of output, widgets of 1, is this a good place to be? Well, let's consider it. In producing that unit, that first unit, how much do we gain? We gain 131. That's the price of the product. So in selling it, that's what we would get. But how much did it cost to produce? Well, it cost 90. Okay. We're in a good situation here because we received more than it cost to produce. The difference between these is what? Profit. Good. Now, let's continue. At this next unit, we yield 80 in marginal cost, meaning the costs are going down, but we again get 131 in revenue. This is even better for us. Okay? And then as the marginal cost goes down from 90 to 80 to 70 to 60, then it changes direction and starts going back up. This is very characteristic of marginal cost curves, where they are first downward sloping and then upward sloping, kind of like a check mark. And we'll see a picture of that in a moment. As these costs continue to climb, we are asking ourselves as producers the entire time, is it worthwhile to produce the next unit? Now, when we get to the point where at unit number 8, it costs us $110 to produce the unit, but we're still getting 131. It is still advantageous for us to continue to produce. At the 9th level of output, it costs us 130, and we're gaining 131. This is still advantageous, and we have to ask the question, should we again produce the next unit? But the next unit of production at 10 costs us 150, but we're only able to yield 131 at the cash register. That means that it's costing us more to produce than we can actually acquire in the sale of the product. The marginal cost is now greater than the marginal revenue, and any profit maximizing firm would reduce the level of output in an effort to equate marginal revenue to marginal cost. Note here that in the profit loss category, we are also maximizing profit, $299, at the 9th level of output, just as we did in the total revenue, total cost approach. Using the total approach or the marginal approach should yield the same result, and it's always safe to check yourself using both approaches to ensure that you have acquired the level of output that will maximize profit. Graphically, we can see several things here. First, our price, which is also our demand curve, our average revenue and our marginal revenue in this case being in a perfectly competitive market structure, is a horizontal line. However, our marginal cost curve, first going down and then going up, similar to a check mark shape, we can see several things here. In the area between the purple and the blue here, this is the area where we would yield an economic profit. Different from the total approach in looking at the gap between the two, in the marginal approach, you would continue to ask yourself, is there any advantage in producing the next unit? And if there is, you would continue to produce the next unit. Any area in here, you could see that marginal revenue is greater than marginal cost. And if that is the case, the decision that the firm should make in regards to an action should be to increase their production with the goal in mind of equating marginal revenue to marginal cost. Any point beyond this, where marginal cost is now greater than marginal revenue, is suboptimal for the firm because they are losing money and producing the units beyond this equilibrium point. Let's summarize what we've just said. In a point here, A and B, where marginal revenue is greater than marginal cost, any profit-maximizing firm would opt to increase their output levels in an effort to try to get to the spot where equilibrium lies, where marginal revenue equals marginal cost. This is the goal of profit maximization according to the marginal revenue, marginal cost approach. Notice element E of your task asks a similar question. The second summary point is as follows. At point C here, notice that now we are at a point of production where marginal cost exceeds marginal revenue. Accordingly, it's costing more to produce that unit of output than you're acquiring in the sale of the unit of output. And any profit-maximizing firm would opt to decrease their level of output in an effort to acquire the equilibrium point where marginal revenue is again equal to marginal cost. Note that element F of your task asks a very similar question. Now let's talk a little bit about the different market structures in order to make a segue into our monopolistic competition sphere. How do we know if a firm is monopolistically competitive? Well, let's start by our understanding of whether or not a firm is oligopolistic. Now, bear in mind that if a firm is a monopoly, then we have one producer of the product. If it is an oligopoly, there could be a handful. And we have to decide a place to draw a line in the sand in order to distinguish between these market structures. It is very commonplace to use the four-firm concentration ratio in an effort to delineate which market structures, which industries are considered to be oligopolistic in nature. In order to qualify as oligopolistic, you have to have the four-firm concentration ratio result in a number that is greater than 40% or 40. Here we can see that these numbers are all lower, and the majority of market structures or industries in the United States currently operable are within the monopolistically competitive sphere. In fact, one quick way of identifying them is by looking at their advertising. If they can afford to advertise, it's likely that they are monopolistically competitive. So anything that you would see on billboards or in advertisements in the newspaper or on television would likely fit under the umbrella or auspice of monopolistic competition. Here we can see things like plastic bags. The four largest producers of plastic bags comprise 23% of the market structure. This number would have to be 40% in order to be considered oligopolistic. Some samples of oligopolistic industries are as follows. As you can see here, the four largest producers of beer comprise 91% of the market. In regards to aircraft, it's 81%, and alcohol distilleries, 71%. These are considered oligopolistic, where only a handful comprise the vast majority. Consider the differences here now between monopolistic competition and perfect competition. Notice in perfect competition we have this marginal revenue curve, which is the demand curve, which is also the price, that's completely horizontal or perfectly elastic. We still have a marginal cost curve that is downward sloping and then upward sloping, which is very indicative, and we see something very similar over here. Notice now, though, that the marginal revenue curve in monopolistic competition is downward sloping. We will see this bear out in the data that we'll look at in just a moment. Marginal revenue calculation in element B, you are asked to explain the calculation used to determine marginal revenue. We presented this several times throughout this presentation. One last time, marginal revenue is the change occurring in total revenue resulting from the sale of one incremental or one additional unit of output. Again, remembering that total revenue is equal to price times quantity. In addition to explaining this calculation, and not just listing it in your task, it'll be important for you to also adhere to what is asked for in B1, where you discuss how marginal revenue increases, decreases, or remains constant within the given scenario. In explaining the calculation used to determine marginal revenue, please note that a discussion of marginal revenue calculation is in Chapter 8 of the McConnell text, page 165, under the subheading Average, Total, and Marginal Revenue. Here we look at some data. This data, again, is not the same data that you will be using in your task. It's data I've created that is closely matched in principle to help you understand the precepts and concepts of marginal and total applications of revenue and cost. Here we start with quantities 0 through 15 and corresponding total revenue denoted by TR and total cost denoted by TC. In an effort to understand this, let's look at this very quickly. At the third unit of output, producing 3 widgets, the total revenue is $336 and the total cost is $88. Here at the 15th unit of production, our total revenue is $960 and our total cost is $1,342. You should quickly see that I presented 2 situations that are completely different in consequence. In the first situation, we find that total revenue is greater than total cost, which means that you would yield a positive economic profit. Whereas in the case of 15 on quantity output, total revenue is now smaller than total cost, meaning that we're now actually at a business loss. But what about the marginal side? It was important in your task element that you discuss how marginal revenue increased, decreased, or remained constant with your given data. Let's gain some practice. Here, I've taken off the total cost column and instead included a marginal revenue column denoted by MR. Marginal calculations for revenue and cost are not given to you in this task. It is required that you calculate them yourself and you explain the nature of the relationship. Let's look at how we calculate marginal revenue. Remember that marginal revenue is the change in total revenue over the change in quantity. For the first unit of output in quantity, total revenue is 120. By how much did that change? From 0, it changed to 120. Accordingly, marginal revenue would be 120. What about for the second unit of production? Moving from a total of 120 to 232, the change was 112. Accordingly, marginal revenue can be computed as 112. Another way to do this is to say 232 minus 120 leaves 112. This process should continue until you've computed the marginal revenue values for each corresponding quantity value. As you can see here, marginal revenue goes from 120 down to 8. Remember that in the perfect competition world, marginal revenue stayed constant at 131 in our example. Here, marginal revenue is decreasing. This is indicative of a monopolistically competitive market. How does this look on a graph? This is one way that you can illustrate the relationship in not only talking about how it decreases over time and giving specific calculations. You're also welcome to show this table and present this in your task, along with the chart. The chart and graph would be helpful in including in your task. Notice you can see here very clearly that as we increase in the units of production, our marginal revenue declines. In element C, you're asked to explain the calculation used to determine marginal cost. And very similarly to the last element, to discuss then how marginal cost increases, decreases, or remains constant in the given scenario. One more time with marginal cost, remember that marginal cost refers to the change that takes place in total cost resulting from selling one more unit of output. The math can be seen here, remembering that total cost is derived from both fixed and variable cost computations. After you state the equation and then describe the equation in words, then it will be important for you to discuss how marginal cost changes with the data that you're given. If you'd like more information about the marginal cost side of things, please refer to Chapter 7, more precisely page 149, for further clarity. Now let's look at marginal cost with our data. In order to do this, we start again with our total revenue, total cost. Let's get rid of the total revenue column to keep things simple. Marginal cost is derived simply from total cost and quantity numbers. Here at 0, we know that total cost will be equal to marginal cost. Note that the costs are positive when Q equals 0, where this was not the case on the revenue side. Now, in your mind, can you tell me what marginal costs will be for the first unit of production? You can do this several ways. You can ask by how much it changes from 11 to 33, or you can take 33 minus 11. Since we're only changing one unit at a time, we're always dividing by 1, so the marginal cost computation is always the change that takes place in total cost from one unit to the next. As you can see, from 11 to 33, we change by 22. This calculation can continue for the remainder of the column. As you can see here, marginal cost goes from 11 to 22, stays at 22, goes to 33, seems to increase here by units of 11 for a while. You can see that it goes up incrementally. What does this look like on a graph? Here you can see that the marginal cost curve increases in conjunction with quantity. Again, as you explain the relationship of increasing, decreasing, or remaining constant for your task, please consider using the chart and graph as you explain what's taking place in both. Now, critical, you will also have to calculate profit maximization using the data that is given to you for Company A. We will go through this with our data, which is very similar to the data that you'll be using and the process that adheres. Again, remember that profit maximization uses one of two approaches. Both will arrive at the same place, and I suggest and recommend that you use both in an effort to ensure that you have arrived at the right answer. Bear in mind, as a reminder, that profit maximization using the total approach seeks to identify the largest gap between total revenue and total cost. Whereas in the marginal approach, profit maximization is the area in which we equate marginal revenue with marginal cost. Let's calculate the profit maximizing quantity using the total revenue, total cost approach. Remember that the total revenue and total cost and the data beneath these will be given to you in the task. The marginal values will have to be calculated on your own accord. In an effort to calculate profit, remember that profit is total revenue minus total cost. I've created a third column in order to identify this. Total revenue minus total cost, which is profit. Here you can simply use Excel if you're savvy with computations, or you can do this with calculator or by hand. All you need to do is subtract whatever is at that quantity. The total cost needs to be subtracted from the total revenue. Here you can see nothing was generated in revenue, but our costs were still 11. Accordingly, we actually have a loss of 11 when our quantity is 0. For quantity of 1, our total revenue is now 120, which we need to subtract 33 from because of total costs, leaving us with a profit of 87. Notice that the profit goes up from 100 to 200 to 300. Here at 347, we find our maximum value because anything beyond this falls. In fact, once we get to 13, we find here in this example that we're again running a loss. When we talk about profit maximization using this total revenue to total cost approach, you should identify profit maximization in accordance with the quantity variables produced, meaning that when 6 widgets are produced, we reach an optimal level of output, profit being maximized. Anything less than this or more than this will yield a lower degree of economic profit, or potentially, if low enough or high enough, a loss. How does this look graphically? Here, I've simply used these columns and created a chart in Excel. You can see the top one here. This is our total revenue curve. The bottom being our total cost curve, noting that the total cost curve will eventually again cross. Remember that anything inside here yields an economic profit. However, there's only one point at which economic profit is maximized, and that's where the gap between total revenue and total cost is greatest. In our example, when quantity equals 6. Now let's turn our attention to the marginal side of the equation. Here I've taken the columns that we've created from marginal revenue and marginal cost and paired them up next to each other. Remember that you are required to calculate the marginal values for revenue and cost. These numbers will not be given to you. Again, as a reminder, the profit maximization criteria using the marginal revenue to marginal cost approach seeks to equate marginal revenue to marginal cost. Let's look at this and see if we can come up with an answer. Let's look at quantity equals 1. At this point, our marginal revenue is 120, where our marginal cost is equal to 22, meaning that if we produce the first widget, the gain would be 120, whereas the cost would be 22. And we ask ourselves the question as a producer, is it worthwhile to produce this first unit? The answer would be yes, in all cases where marginal revenue is greater than marginal cost. Whenever you're at this point, you want to consider not only producing this level, but you want to consider taking advantage of additional profit by producing more. If we continue and we find a point at which here at 6th level of output, our marginal revenue, although having fallen from 120 to 80, is still greater than the marginal cost at 66, noting that 66 is getting larger. Okay, our marginal cost is getting larger incrementally until having arrived at 66. Here, the 6th unit of output is still worthwhile in producing because 80 is greater than 66. And again, you have to ask yourself the question as a producer, is it worthwhile then to produce the next unit? When we consider that question through the vantage point of quantity equals 7, we arrive at a specific answer. More specifically, marginal revenue at the 7th unit of output is equal to 72, meaning that our gain would be $72, whereas the cost would be 77. Our cost here is greater than our benefit or the revenue acquired, meaning that this is no longer optimal. This is no longer worthwhile, and we should reduce our output back to the 6th level of output in quantity. Again here, note that the 6th output level of quantity is the same answer that we arrived at in the total revenue to total cost approach. This should be what you find in your example. When we graph this, we can see several things. First of all, note here that the 6th level of output is the level where profit is maximized. Why not the 7th? Well, while it is possible for the crossing to take place exactly at the unit of production where marginal revenue equals marginal cost, oftentimes that doesn't take place in real life. Here we find that when we move to the 7th, we're already in a world where marginal cost is now greater, meaning that we are beyond the level of output or production that is beneficial for the firm. So the sixth level of output, assuming we can only produce in whole units, is optimal for this organization. Any point before this where marginal revenue is greater than marginal cost suggests to the firm that you should continue expanding your output or production in an effort to reach the point where marginal revenue equals marginal cost. Also, any point beyond this, where we're anywhere from 7 to 15 units of production and marginal cost is greater than marginal revenue, any profit maximizing firm would get the clue that they should reduce their level of output in an effort to minimize loss or maximize profit. E asks to explain what action should be taken in terms of adjusting output if it is determined that marginal revenue is greater than marginal cost. In this theoretic example, using our data, assume that we are at output level 4. This is a level where marginal revenue is greater than marginal cost. What action should be taken in order to maximize profit? The firm should continue to expand production in an effort to reach the point at which marginal revenue equals marginal cost. Element F asks a similar question. Explain what action should be taken in terms of adjusting output, but here we're looking at the case where marginal cost is greater than marginal revenue. So suppose we are looking at producing 10 units of output with our data. Here we can clearly see that marginal cost is now greater than marginal revenue. What action should be taken by the firm in an effort to maximize profit or here minimize loss? We're looking at reducing output with our eye on the point at which we can equate marginal revenue to marginal cost. You can see that regardless of where we are in our quantities here, when we're using the marginal approach, we always look at equating the two. That's the point at which we're going to maximize profit. And when you find that the number seems to match with the total approach, then you know that you've arrived at the right answer. This wraps up the presentation for EGT1, Task 1. I hope you've enjoyed this presentation. Please make use of the resources in the community pages and have a great day. Happy studies from the economics team here at WGU. Goodbye.